Probably most of you are aware about my presentation in US MAM, because as far as I know, in the MikroTik forum, it's one of the most popular presentations from the MAM ever, because there's lots of topics, and almost all topics with QoS is with this presentation. So this one is an updated version. I tried to solve some questions that arise when somebody passed a previous version of presentation. I hope it will be a good help for you in the future. So let's start. So first of all, please do not confuse the reasons why I created this presentation. So this presentation is for guys who already have a working QoS system in one router, and they want to have two QoS systems in the same router. So the first question that this presentation will answer to you, is it possible to prioritize traffic and have strict per user limitations at the same router? So yes, it is possible. So what will you need to achieve that? You need to know a packet flow diagram. So who can tell me where is our latest packet flow diagram? Who have seen it? Please raise your hand. So raise your hand who have seen it. Yeah, it will be not enough. So guys, in the wiki page there is a packet flow diagram which shows exactly what's and when are going on in the router OS. Then you will need to know at least something about HTTP. So for those who doesn't know the abbreviation, it's Q3. Then we will need to know something about Mangle, PCQ, and address list. Those are the 5 things necessary to know about to create this setup over here that we will be discussing. So let's start with one of the things, this Mangle facility. So allows you to mark packets with specific marks, and these marks can be used for 2 different purposes. One is for queues, another is for routing. We are not interested in routing in here, so we will talk about queues only, so packet marks. And additionally, if you need, in the Mangle you can change IP header, fields in IP header, like TTL, type of service, and others. So then the other thing is HTB, or hierarchical token bucket. So basically there are several ways how limiting or queuing can be implemented. HTB is the one that we chose, and all the things related to queuing, that's simple queues and Q3, are basically implementation of HTB one way or another. So HTB allows you actually to create this tree structure, and it defines the way how the childs related to parents and between themselves. So basically all that you see in Q3, all those limited, max limits, priorities, and the structure is nothing more like HTB. And if the MikroTik doesn't have enough materials about it, try to type in HTB and you will have lots of open source documentations about this topic, and we have only visual interpretation of this particular thing, so you need to look not for Q3 but for HTB for more information if it's necessary. So, and we have 3 virtual HTBs called global in, global out, global total, and one more just before every output interface. So this is the cutout from the original packet flow diagram. So I left here only the Mangle and HTB stuff. So nothing more. Everything else is kicked out. So as you can see, when the packet arrives, it really doesn't matter. Does it arrive through local interface or to public interface? All interfaces, when the packet comes to the router, are considered as an input interface. So please do not make mistakes, because most of the some of my customers who write to me think that this diagram works like for one direction that way, and when the packet is answered, it comes back. No. All packets, no matter what packets, are starting over there and finishing over here. So input interface is the interface where the packet came into the router. That's it. Local, bridge, output, it doesn't matter. The interface where the packet came in. We have a Mangle pre-routing, so the first place where we can mark traffic. Then we have a global in and global total. You probably know that global total is global in plus global out. So in case you have limitations, not for download and upload separately, but you have together, maybe some of you use this type of limitation. Raise the hands who use the total limitation. 1. Okay, so most popular are upload and download. Then after global in, after the routing decision actually, which is cut out from here, traffic divided into two streams. One stream is the traffic that goes to the router, it's Mangle input, and other stream that's going through the router to the customers. So forward. After the router made an answer, it made its own new packets, and they are going through Mangle output. So basically then they both come together in Mangle post-routing. So as you can see, there's no queuing place in between Mangle forward and Mangle post-routing. So the only difference from our queuing perspective is like in Mangle forward we have only customer traffic. In Mangle post-routing we have a customer traffic and the router traffic together. So might be a good thing to make a little more attention when you use a proxy in this case. So do you want to limit proxy or you don't want to limit proxy traffic? Then after the post-routing it goes to a second place where you can limit traffic. It's global out. And of course the second part of global total. And afterwards, after the routing decision over there, also cut out from this diagram, it will divide in the third place where we have per interface, per output interface, HTB. So if you have 3 interfaces, you have 3 output interface HTBs. If you have 10 interfaces, you have 10 output interface HTBs. So all the packets that will leave via either one will go to the either one HTB. It will not be captured by any other HTB of output interface. And then packets just leave through or are dropped or leave through the output interface. So that's the way which we should be concerned when we talk about mangling and queuing. So basically, if we want to do 2 queuings and 2 manglings in the same router, so what can be the logical places where we can mangle for the first time? Mangle chain pre-routing. And where we should queue for the first time? What place? Global in? Global in. So we can finish our first queue system, first QoS over here. So we get the rest of this diagram free for our second QoS system in the same router. So what can we choose for the second mangling? So only post-routing or forward. It's free. You can choose either one. And to limit this second traffic, second market traffic, you can use what? Global out or out interface. It's again up to you. double QoS is only possible with Q3. So logical question, why not simple Q? They are so simple. So as I told already in yesterday in Birds of the Feather, we have our meeting over there. Simple queues was designed for simple queuing. So if you have simple tasks, you can use simple queues. Because as soon as you go to the complicated tasks, that simple queues are not so simple anymore. So I suggest to go to Q3. So the reason why we are not using simple queues are very simple, actually. So 2 reasons. One reason, simple queues are ordered, same as the firewall rules. So if you have 999 queues and the packet should be captured by that queue, that packet will go through all 998 other rules to get to that last one. So it will result in one thing, in bigger latency for your customers. Other thing, each simple queue might stand for 3 separate queues. Why? Who knows why the might part is here now? So nobody of you used the total part. I don't know, in one of the versions, 3.something, we changed the thing that you need to change at least something in the queue to make this queue work. Who of you had a problem that my graphing doesn't work? So simple queues doesn't work anymore and needed to change from default small to default. I answered at least 100 mails like that, so anybody here, don't be shy. So at least 1, 2. Okay, so it's normal. So you need to change at least something in particular part of simple queue to make it active. If you don't change anything in there and it's by default, we think that you don't want to use that part of simple queue. So in that way, we make our routers a little bit faster. No more global total queues at all, because almost nobody uses them. If you want to use it only for upload, you select options in upload, and download queue will not be created. So if we take a look at our diagram, that global in is there, global out is there. So the only place where you can mangle traffic for the simple queue is pre-routing. If you mangle it in mangle forward, what will happen? Who knows? What will happen if we will use mangle in different chain for simple queues? Anyone? I know for sure at least 3 persons here who know for sure. Only one direction will work. In this case, upload will not be limited. Any of you have any problems with unlimited upload? So probably that's because you were mangling in the forward. And as you can see, if you mangle here, you cannot limit that mark here because it's before. So simple queues allow only 1 QoS per router. If we want to have 2, we have to use Q3. So the Q3 is only one directional. So if you want to create full download, so instead of each simple queue, you need to actually create 2 Q3s. One for upload and one for download. But Q3s don't have any order. So all the traffic goes through the system, this HTTP, simultaneously. So it doesn't have this setback that simple queue had. But all childs must have a packet marks assigned to them. So you have to use mangle facility of router as firewall part. In simple queues, you can avoid that part, but if you use Q3, you must use Mango. And very popular question, what happens if I place a simple queue and the Q3 queue in the same HTB? So let's say global in or global out. Then simple queue will take all the traffic away from the Q3. So the simple queue will work, Q3 will not work. It's also a very popular question. I think I can say more than 100 for sure questions why my Q3 doesn't work, because you have some dynamic simple queues or something like that. So now we go to the logical question about what to choose. So for the second limiting, we had two choices, global out or out interface queue. So what's the difference? There's two differences, and I would say two big differences actually. First one, in the case of source NAT, so if you use Masquerade on your router and clients have private addresses, global out will be aware, will see the local addresses, but out interface will not. Because, maybe somebody can say me why. Exactly, because source NAT is located in post routing and happens after global out. So basically, to the interface queue, we get only already NATed address, only one local address, and then that actually means one thing. You cannot use PCQ for upload separation, in this case in output interface. That's one of the most common mistakes. And again, mistake comes only for one reason. Nobody knows about packet flow diagram. So if you intend to do some advanced queuing, I really suggest to print it out and stick to your working space near your laptop. Because this is the only way how to know what happens when. And if you don't know this sequence, sorry guys, but you will not be able to create a proper advanced QoS system. And the good thing about out interface is, if you don't use Masquerade with the PCQ at the same time, is you don't need to separate upload for download, because it will separate automatically, automagically. The all traffic that will leave the public interface basically is what? Is client's upload. And all traffic that's leaving local interface is always a client download. So upload and download are separated automatically because of the leaving interface. So that means if you use out interface queues, you do not need so complicated Mango system. You don't need the separate marks for clients up and clients down. You just need one mark, clients, and it will separate by itself when it goes to the out interface queue. So let's make some conclusions of it. So for this setup, we will use Mango and Q3. The traffic will be first marked in Mango chain pre-routing. Then we will limit it in global in HTB. Then we will remark traffic. In my case, I don't have any proxy or something. That's why I will stick to the forward. And I don't have a Masquerade. So that's why I'm a lazy person. I want to simplify my Mango rules. I will limit traffic on the interface HTB. The only thing that we need to keep in mind now is to keep our Mango rules and amount of queue to a minimum, so that we can increase the performance of this configuration. So let's see what can we do in this situation over here. So a typical situation for at least ISPs in my country. So you have an internet connection And then you have 3 connection types. Let's say I call it business, standard, and basic. So each client, when he wants to connect to you, can ask for business, basic, or standard connection. So I think that you have something common. It should be. So let's take a look how we can manage this one. So the only way how to reduce number of queues, so by default you can say it's 1 queue or 2 queues per customer, but we need to reduce that to increase performance. So the only thing that we can do is to choose queue type PCQ. So per connection queue, this one is actually made by MikroTik itself. I don't know if you have PCQ implementations anywhere else, but the first one it was introduced by MikroTik. So this queue type is capable to divide traffic into substreams based on classifiers, and we have only 4 available classifiers over here. So source NAT, source address, destination address, source port, destination port. That's it. No more other classifiers. So you can specify the speed of each subqueue by PCQ rate, this option over here. So if you specify there 2 megs, then each subqueue will get 2 megs. Also, you need the queue size for each subqueue. You can do this here, limit option. So limit is not the speed in here. It's the size of the subqueue. And the total limit is the size of the whole PCQ together. So basically, the process in PCQ can be divided in 3 parts. First part, grouping by classifier. So let's imagine we have a traffic that's leaving through the local interface. And we choose classifier destination address. What will be the substream? So leaving through the local interface. Leaving through the local interface means that destination addresses will be your client addresses, correct? So if we divide it by destination address, that means that each substream will actually represent a client download, correct? So this way, instead of having 1 queue per every client, you can have 1 PCQ queue with classifier destination address for all clients. And each substream actually works as a first in, first out queue, the simple way for each substream. Then it goes together, and the only thing that in the third step we are interested in is the queue size, so that there will be enough packets in the memory to have appreciated performance, I would say. So what happens if we don't have a queue size at all? If the packet cannot go through, it is dropped. It has bad and good things. We will get to that a little bit later. So basically we need, in our setup that we're discussing here, we need 2 types of PCQ queue. One should be a PCQ upload, destination address as classifier, or am I mistaken here? Is it correct or no? Yes, it's correct. I'm just checking it out. So this client upload, where the traffic is going. Let's think. So upload, where it is going. From the client. So is it correct or no? Okay, thank you. So few beers left me also with some mistakes. So in this case, it's the other way around. I will fix it, and there will be in materials that will be correct way. So for the upload, we need the source address, and for download, we need the destination address. This PCQ will distribute available traffic equally between sub-queues until the PCQ limit or PCQ rate is reached. So let's take a look over here. If the PCQ rate is 128K and you have a max limit of that queue 512K, and you have, let's say, middle of the night, and you have only 2 customers up. So this solution over here, they will get designed at 128K as the PCQ rate set. But as soon as there will be more customers, PCQ will try to divide the traffic, available traffic, which is 512K, equally. So in 7 client situation, it will be 73, around 73. But you can also leave PCQ rate to 0. And in this case, if only 1 client will be online in the middle of night, he will be able to use all the traffic. If 2, they will divide it in half. And again, if there's 7, it will be the same situation like previously. It will also be equally. So that's the main thing, how the PCQ works. So, queue types. Let's now, in here you can see I have created those queue types that we discussed here. So, for up is the source address, and for down is destination address, and this time it's correct. It's not like in previous slide. So I have 6 queue types. If you remember my one of previous slides, I have 3 connection types: business, standard, and basic. And there I have 3 downloads and 3 upload limitations, PCQs. So for each type, 2. Now we optimized queues. Now we need to optimize our firewall rules, our mangling system. So how to mangle more, how to have the same effect with less mangle rules. We should use address list. It is one of the features introduced in version 3.0. So you can assign a multiple IP addresses or ranges to the same IP mangle rule. So there's 3 ways now in latest versions how you can create your mangle rules. One, of course, is manually, the easiest way. Then we got a lot of complaints from guys who have a big PPPoE servers, and they of course make a limitation automatically and have 1 simple queue per client. So if you have 1,000 clients, through your PPPoE, you have 1,000 queues. So how can I avoid it? There's a new option in PPP profiles called address list, which will automatically, as soon as your client connects, put that IP address to the address list. And now you can use the address list the same way as you would prefer to do when you created it manually, to have a queue tree. And of course, most of the guys want to specify limitations in radius. And in the latest versions, I think 3 or 4 versions ago, a radius attribute, MikroTik number 19, was added. So you can also use radius to assign IP addresses to the proper address list. So you have all the necessary ways how you can add. Questions will be afterwards, okay? So all the possible necessary ways how you can add addresses to the address list so we can use them for our queuing system. So if you're wondering where the address lists are, so IP firewall, last sequence address list, and there's an example of my particular setup. So I have a basic client, standard client, and the business client. So where? We already decided that we have, if we want to have 2 QoS in our one router, there's only 2 possibilities. So we also decided that we want to prioritize traffic and then have a strict per user limitation. So what is more logical? First, to have strict per user limitation and then prioritize traffic, or other way around? So what is more logical? Other way around. So per user limitation is better to be placed in these places over here. So mangle in forward and limitation in out interface. So let's speak about packet marking. I will not go into the big details about how to mark. I would just introduce you with the favorite way how you should do it. First of all, use connection marks. So you can use them with addition of address lists that we already have, and mark all connections of basic clients, all connections of business clients, and all connections of standard clients. So have connections divided in 3 separate groups. Don't worry about such thing as upload connections and download connections. For simple reason, there's no such thing. We have upload packets and download packets. We don't have upload connections and download connections. And you don't need to capture both ways for simple reason. In the TCP, for example, if you don't capture the first SYN packet, you will always capture the answer packet, ACK packet, back. So why bother? Are you really bothered about first SYN packet not limited? Not really. So, and then have a rule that will mark packet from these connections. Mark all packets from these connections, that's all. But there's some questions that I don't have answers, but you should think about. So, what in your ISP, what policy do you use when a business client are downloading something from basic client? So, should it get the business client speed, or should it get basic client's upload speed? It depends. And depending on this answer, you just need to rearrange your Mango rules in the right order, and you can have either way. So just think about it. And there's always a chance that somebody or you forgot to add something to address list. So be careful about unmarked traffic after you think that you mark everything. So a simple log rule would do the thing. So those rules, as I told you already at the beginning, I will show everything that I'm doing. So this rule over here, mark all the connections for basic clients. This rule over here marks all packets from basic client connections. And in the end, in my setup, I have a Mango that looks like this. I have 3 types of clients, basic, standard, and business. And I have, very interesting, 9,000 packets of something unknown, which I need to take care about in the future or something. Just take a look in the logs. So I really suggest to choose your packet mark names properly. It's not that we have a limited space to name them. Because if you ask somebody, and personally, that's me usually, in the MikroTik support to please help me with this Mango, if there's no comments, and the packet mark names and connection mark names are completely unfamiliar for me, then I probably will not be able to help you because it will take few hours for me to get through. But if you take a look here, do you understand this? So, is it hard to make something like this? So please, thank you. And for those guys who want to just copy and paste it, as soon as this presentation will be in PDF, you can do it from this slide over here. There's no other reason for it. And Q3 in the Winbox. Also looks very simple. I have 6 PCQs. So I assign the packet marks. I also assign those Q types that we created previously. And I assign them to the interfaces. And by the way, you can also rename your interfaces. Public Ether3. So I know that it's a public, and I know that it's Ether3 on my router board. It really helps a lot if you use the old features. So, again, page for those who want to copy. And one more thing that after you created all this that we discussed, there's usually one big problem. You forget about queue size. You actually need to change those options pretty often. Not only leave in default. So by default, it will take only 40 users, 40 active users, let's say peer-to-peer guys who are downloading movies from torrents. Only take 50 guys or 40 guys to make your PCQ queue completely full. 2,000 packets full. So the next guy who will try to download something with those guys in the network will have dropped packets because there's no place to queue them. No place for packets to wait until they can be sent out. And then there's where the packet loss come in. So maybe some of you have something like packet loss not on wireless networks. I'm not speaking of wireless now. I'm speaking about wired network, more or less. So queue size can be one of the reasons why you have a packet loss. So if you are worried about how much RAM will it take, it actually doesn't take much. You can see calculations there. So if you have 2,000 packets, it's around 4.5 megabytes of RAM. Not bits, bytes. So our suggestion is to change limit at and max limit so that you will have at least 10 to 20 packets for each client always. So if somebody has been to our official wiki page manuals, there's one about queue size. And with this example that I have over here, I explain why you should have at least some queue size. So if you want, I really suggest to go inside and investigate what happens if the queue size is 0, how much packets are dropped, and what happens when the queue size is unlimited, which is not possible in RouterOS, but still theoretical. So in this case, packets with the different colors are 1-step delay or 2-step delays. So what's bad and what's good in this situation, it's really a long discussion. I just want to say that information is available to you. And after that, you should understand that 10 to 20 packets per client in PCQ should be sufficient. Maybe in your case, you need something else. It depends. It always depends on something. So in my setup over here that we are discussing, I suggest to change, as we have around 340 basic users. PCQ limit we will set to 40. 40 times 340, it's around 7,000. So let's put a 7,000 there instead of 2,000. And the same thing for other things. And the one thing, the more speed the client has, the less queue size you can select. That's the suggestion also. So, and now let's shortly talk about packet prioritization. So, there's some little problems with online communication such as video, audio, VoIP, and most problematic thing, games. So, the task is to prioritize the traffic. So basically in here, I don't know the ideal answer, how to do it, and didn't I forget something? But usually the user requests are something like this. So they want high priority to DNS, SSH, ICMP, Telnet, HTTP requests, that's browsing, homepage browsing, and HTTPS, then games, then VoIP, Skype, and any other video conferencing things. And of course, the lower priority can go to the mails, HTTP downloads, SFTP and FTP, and of course, the worst of them all is peer-to-peer. So those who were with me yesterday evening after the MAM at the discussion about peer-to-peer, who can summarize what was the result? So please, anyone. There was 40 people there, so at least one. Okay, let's say you are afraid. It is impossible to capture encrypted peer-to-peer now with any means whatsoever. So there's simply no way, because those packets are just have nothing common with each other. So we cannot find anything common to capture them, so you can limit them. That's why the right approach for this solution is to go other way around. So instead of trying to limit peer-to-peer traffic, you need to prioritize everything else. And that's basically the concept that you need to think about, because half of you here are concentrating only on one thing, limiting peer-to-peer. So it will not work, sorry. Sorry to disappoint you, it will not. So please stop thinking in that direction and start thinking in another direction. You need to prioritize all the known traffic that are good to actually get peer-to-peer down. And then it will start to work. So we already used two places to limit and to mangle and to limit traffic. So now we have left only pre-routing and global in to do a prioritization. And this is a table of my suggestions. What should you use to capture that particular traffic? So this one over here is actually options from IP firewall. So to create from this table a firewall rules, it shouldn't be a big problem. So please don't say that my presentation is not finished. I simply give something to you that so you can write on your own. And these are only suggestions. As we already yesterday discussed, we can use a web proxy to eliminate traffic on port 80. Sorry. And we can use all the other interesting things to fight against peer-to-peer. And one of the best conclusions was about Skype. So if we cannot capture Skype, we cannot prioritize Skype. So you should all write to the Skype developers the mail that we want to prioritize Skype. And then maybe we will be finally able to live with it. So, and then just use the priorities like assigned here, make up some limits. As you probably know, I suppose you know, priorities in HTTP works only when there's a limitation. If there's no limitation, there's no priorities. So that's about it. Thank you.
So, thank you, Yanis. Maybe somebody has some questions. Yeah.
When you mangle packets in only per routing, it's not me, will the packets be queued twice in global total?
It depends how you mangle it.
But on your picture...
So, yes, global total, as I told you, is a global in plus global out. So it happens either way. It will not happen twice if you configure everything normally.
Thanks.
Any more questions?
If I do a traffic limitation in a different router from the PPOS server router, how I can add the address to my address list in the other router? Because I have many access points with their...
So you want to use firewall in one router?
Yes.
And by those results, create an address list in another router?
Yes.
That sounds more like a scripting thing to me. Yes, you can use a type of service bits to identify some traffic.
Change the type of service.
Yeah, and then from that change you can capture that. Yes, that's a good idea. Thank you.
Okay, thank you.
Eisenguler.
So basically what you told, so can we use dynamic queues and queue trees together?
If you know how they interact, yes.
So how they interact? That's the basic question.
So basically, in simple terms, if they are both meant for the same traffic, only one will work.
Not for same traffic. Let's say we want to limit the users.
If it's completely unrelated traffic, then you can limit one traffic in simple queue, another traffic in queue through without any problems.
But the traffic could be the same, you know. Prioritize the traffic, you know, let's say HTTP or something else, and the whole traffic of the user.
Yes, but this whole traffic of the user consists of the traffic that you prioritize.
Yes.
In HTTP, the traffic can be captured by one instance. That's all. It will not get to another. So if we are talking about traffic that overlaps,
yes,
you cannot use simple queues and Q3 in the same HTTP at the same time.
So you cannot. Thank you.
Any more questions? Please raise your hand.
No.
And you can leave that microphone there.
No, thanks. Technician question. Is it possible to set address list in profile of PPP and add the clients to the second address list by radius response?
At this point, I can't see why not. I think yes.
Well, it's just a realization. So
okay, if it's not possible, it's very logical thing to do. So if that feature is not introduced,
then write to support.
Of course.
Thanks.
So, more questions?
It sounds like you're all really confused.
I'm sorry.
This is a question not related of what we talk now, but I want to know if it's related. It's the WMM protocol, the one on the wireless for QS. If it's possible to use it with the queues And
It's completely unrelated. It's a completely different layer. Yeah,
Use
it's
DSCP.
a hardware. It's layer 2. It's layer 1 even.
okay.
So, but you can use the combination of both.
Okay.
It's
The
no
access
problem.
side. Okay.
How would you connect it with hotspot when hotspot does user limitation dynamically?
Hotspot also has address list option, same as PPP.
Okay, thanks.
Is an address list is unlimited, or I have about 10,000 address list long, but is it unlimited or not? Address list in filter or in IP firewall, yeah, there is an address list. Is it unlimited list?
Is it dynamic list? Or what was
No,
the
no,
question?
it's not dynamic. It's a list with address IP.
Okay, what is the question?
How big it can be?
Haven't seen maximum yet. Don't know.
I don't think anyone has reached a limit.
So
Probably unlimited then.
my first guess would be, as usual, 65535 addresses, but I don't know. If somebody is very interested about that, I should check, but I hadn't, and one mail which said that your address list is full.
So, unlimited for now.
Okay, any more questions? Okay, if you have any more questions, just come to me. I will try to get an answer. So, thank you very much.
Thank you, Yanis.